हा सर, वी आर लाईव्ह. फक्त एक 10 सेकंद फक्त.
ओके ओके.
सर, वी आर लाईव्ह.
ओके.
Good morning, all of you. Uh, Good morning, all of you. Respected
morning.
dignities, respected dignities, uh, our beloved, respected, honorable principal, Dr. D.G. Kansil sir, respected scientist, Dr. S.D. Pawar sir, respected scientist, Dr. S. Fadnavis ma'am, Dr. Sukle sir, uh, Dr. P.M. Patil ma'am, convener of this national webinar, Dr. C. Patil sir, uh, my colleague Dr. Natke sir and Dulgun sir, technical support Dr. Amol sir, and all the participants. We are here to listen to most our today's guest, Dr. Pawar sir and Dr. Fadnavis ma'am. The Bharati Vidyapeeth, Dr. Patangrao Kadam Sangli was established on 16 September 1985, and on the same day, the worldwide the Ozone Day celebrated. On this occasion, the Foundation Day and Ozone Day, we have organized this national webinar on Ozone for Life, 35 years of ozone layer protection. The theme of this year of this Ozone Day is Ozone for Life. This year, we are celebrating 35 years of global ozone layer protection. Ozone for Life remind us that not only is the ozone crucial for the life on the earth, but we must continue to protect the ozone layer for the future generation. World Ozone Day is observed on 16 September annually. Every year, this day is celebrated as an International Day for the preservation of ozone layer. The purpose of the Montreal Protocol is protect the ozone layer by reducing the production of substances that are supposed to responsible for the ozone depletion. On 19th December 1994, the United Nations General Assembly proclaimed 16th September the International Day for Preservation of Ozone Layer. This Montreal Protocol was signed on 1987, and from that, the ozone protection is carried out. The ozone layer is a common term for the high concentration of ozone at around 50 to 30 kilometers above the Earth's surface. It covers the entire planet and protects us by absorbing harmful radiation. This is a very simple formula for ozone, that is O3, and 90% of the ozone is found in that stratosphere, and the remaining 10% is observed in the troposphere. It is around 30-kilometer altitude. So these two kind of the ozone keep in mind, and we have organized this event, today's event, and we have called two experts, particularly Professor Dr. S.D. Pawar sir will talk about how ozone forms due to the lightning. So the ozone for life will cover by Dr. Fadnavis ma'am. So these two topics are very important for the to understand these two topics is very important for us. Therefore, uh, I would like to here mention that every year we are organizing this event, that is a Ozone Day, World Ozone Day, through the poster presentation, and then student involvement is very important in this case. But due to the COVID-19, it is very difficult to organize such event, and therefore we have organized this national webinar. May may I welcome to all the participants, all the guests in this webinar. I would like to just inform you how we will go further. We just start this event, and our beloved principal will address about our college, and then I will introduce the guest, first guest, our Pawar sir. The Pawar sir will talk about the role of the lightning in the formation of the tropospheric uh, ozone. And then we will discuss a few minutes, that is the 10 minutes we have already scheduled for that. And after that, one more my colleague will introduce Fadnavis ma'am. And then Fadnavis ma'am will talk about the life, ozone for life. And then we will again discuss 10 minutes. And in between that, there is a one more sponsor we have, that is the Ishre, and Mr. Yadav sir is will address about the Ishre, how Ishre is working for to prevent this greenhouse gases, that will informed by the Yadav sir. He will be connected with us and the meanwhile, and then we will finish with the vote of thanks. So now I would like to invite our principal, Dr. DG Concessor. Before I invite, I would like to say something about him, because he is one of the uh, uh, management council member of the Shivaji University, and I'm very happy to say, sir and madam, he is the first person in the Shivaji University got that award, the best principal award, and that is given by the Shivaji University. Last year he got that award, and first time that announcement was there, and he got that award among the, I think, 300 colleges affiliated to the Shivaji University. Out of that, he got that award, and this is a very prestigious award he has received. Uh, he also actively involved in the research in academic. And one more thing, I'm with the permission of Concessor, I would like to inform you. He has also nominated for the uh, Vice Chancellor of Shivaji University. So my best wishes with you, sir. And may I now call you to please introduce our guest about our college. Uh, Thank you. So please, Concessor.
Namaste. Good morning, one and all.
Concessor. Okay.
The chief guest of the today's function, Dr. Pawar sir, Dr. Fadnavis madam, both the chief guests or speakers, they are from IITM Pune, and both them are scientists here. We have along with us here coordinator of NAC of our college, Dr. Suple, Dr. Nade, our technical supporter and actually working as a assistant professor in computer science, Mr. Vande, all the colleagues and dear friends. I'm very happy here to welcome you all for this one-day national webinar on Ozone for Life, 35 years of the ozone layer protection. And for this national webinar, we have called two scientists which are working in IITM Pune, Pawar sir and Fadnavis madam. Actually, I have completed my BSc, MSc and PhD in Pune. And where you are working that particular area, near to that on south side, Bharati Vidyapeeth, Yeshwantrao Mohite College is there. I was there for 30 years as a student, as a lecturer in chemistry. And therefore, I know very well that particular area, NCL, then our institute, IITM, then ISER, Pune University, because generally I went for NCL for reference work. And therefore, I know very well about Pune and this various organizations near Pune. Pawar sir, I think few months ago, we met together in that Ghodawat in University. We have introduced ourselves. Fadnavis madam, today we are welcoming you for this inauguration function of this national webinar. And I will request both of you to visit our college as early as possible. I welcome next time when you are coming to college and for organizing different activities in our college, because we are today, all of you are, whole world is lockdown and we are not meeting each other on this online process we are meeting. I am happy here to welcome you, both of you. We have among us here Dr. Supne, Dr. Nade, then Amol Wande, and my faculty members. They are involved for this webinar. And therefore, for some students are there, they are also involved. And therefore, I welcome all the faculty members and my students for this national webinar. Friends, let me introduce Bharati Vidyapeeth and this Bharati Vidyapeeth, Dr. Patangrao Kadam Mahavidyalaya. Today, I am very happy because today we are celebrating Foundation Day of our college, because since our college is established on 16 September 1985. Before that, let me introduce Bharati Vidyapeeth. All of you are aware that Bharati Vidyapeeth was established in Pune by Honorable Dr. Patangrao Kadam on 10th of May 1964. Friends, the motto of Bharati Vidyapeeth is all-round development of the students, all-round development of the faculty members, and the main objective, that is the social transformation through dynamic education. And therefore, with this motto and with this vision, we are working together for near about from 64 to till today. Bharati Vidyapeeth have all faculties, multidisciplinary faculties. All the main center of Bharati Vidyapeeth is located in Pune, and other centers are in Solapur, Kolhapur, Sangli, Karad, Delhi, Mumbai, etc. And one of the college which is located in Sangli of Bharati Vidyapeeth, that is the Dr. Patangrao Kadam Mahavidyalaya Sangli. Our college was established on 16 September 1985 in Sangli. It is located on the bank of Krishna River. We have arts, science and commerce streams from 11th standard to MSc. We have 5 subjects in arts faculty as a specialization. In science faculty, we have 4 subjects. We have commerce faculty, we have MSc in analytical chemistry. Along with all this, we have in junior college, and especially for junior college, we have vocational stream. In that, again, there are 4 subjects, 4 streams, and that are very useful to the students who are job seekers. And therefore, such a college where all the activities they are carried out. Our college is affiliated to Shivaji University, Kolhapur, and from Shivaji University, and also from other sides, we have taking the help of other people, other resource persons, and we are organizing different activities in our college. And therefore, our college is rich in activities. There we have cultural stream, we have sports faculties, sports students. They won the medals from national, international. In cultural event, we won the universities competitions, different prizes, and therefore such a college where all the activities, national seminars, national conferences, workshops we are organizing, such a various activities we are carrying in our college. And therefore, in such a college, we have gathered here on the occasion of Ozone Day, and at the same time on the foundation day of the college. And therefore, once again, for this webinar, national webinar, I will welcome you all, Dr. Pawar especially, Fadnavis madam, and all the faculty members, all the students. Once again, I welcome you. I wish best success to this national webinar. Thank you. Thank you very much. Over to Nade, sir.
Thank you very much, sir, for a brief introduction of this our college. Uh, Now, I move to the next. First of all, Dr. Pawar sir will talk about the role of thunderstorm in the tropospheric ozone. So before he talk, I would like to introduce him to all the participant. Uh, Welcome, sir. As you know that we are connected last 3 years, and first of all, I would like to mention about him. Because of him, I have established a small center in Sanjay Gauda University that I was working at that institute, and this center is very good for the atmospheric research. This is because of only Pawar sir. Uh, so, respected scientist, Honorable Dr. Sunil Pawar sir, has completed his education from BSc to PhD from Pune University, and since 1991, he is working in the Indian Institute of Tropical Meteorology, Pune. Uh, he has started his career as a junior scientific officer, and now he is a scientist TF. You can imagine that how much experience he has in this particularly research field. Those are the newcomers or those don't know about the IITM Pune. So I would like to mention here the IITM Pune is one of the most prestigious institute, autonomous institute in India, and
हॅलो.
सरांचा नेटवर्क इश्यू आला होता. 2 मिनिट वेट.
येस.
रिजॉईन होतात. Sir, Pawar sir, can we start now? I think there is some little issue.
No.
yes. So sorry.
I request you. Oh, okay. He
Yeah,
joined.
yes,
1 minute.
Sorry for internet corruption. Uh, uh, Dr. Pawar sir has his research is mainly focused on atmospheric electricity, thunderstorm electrification, cloud physics, aerosol science, and I have worked with him, and he is a very kind person. He is a very gentleman that always in supporting mind. He never show any kind of the attitude. He is a big person, but he never show like that. Because of him only, I dare to call him and establish such kind of the activities in previous institute. And here also, because of him only, I could do that. He has a few awards on his credit. So just I read it. Uh, Member of the expert group for preparation of National Desert Management Guidelines for the preparation of action plan in the thunderstorm, lightning, squall, and heavy winds. Here, I would like to mention that he is one person that is very much involved in to build a network of the lightning over the India. He is also the member of the Committee on Cloud and Precipitation by National Atmospheric Research Laboratory, NARL Gadanki. So Gadanki, this NARL is the one of the ISRO center. Uh, he is a member of the subcommittee for drawing outline for the revision of syllabus of a subject like observational system for various IMD training courses. He is also BOS member of the Shivaji University Kolhapur. He is an expert member of the member of Lightning and Thunderstorm Monitoring System Review Committee. Then Satish Dhawan Space Center, Sriharikota. So he has a very dynamic person, and he is a very busy person. And I'm very thankful to you, sir, for accepting our invitation immediately and coming to here to deliver the lecture on this a dynamic topic, that is the how thunderstorm react with this surface ozone, and that kind of the information he will be present. One more thing is here, he has published more than 50 research paper in highly cited journals. Now, I would like to invite Dr. Pawar sir to please continue his views.
Okay, I'll share the screen.
Yes, you can share your screen, sir.
Okay, good morning, everybody. First of all, I would like to thank. Can you hear me? And my screen is visible?
No, sir.
Hello.
No, not
screen
screen is
share.
not visible.
Screen share. Please share the screen. There is option. Sir, खाली option आहे बघा. Mute, stop आणि screen मध्ये.
Share. Okay, now you can see my
No,
screen
sir.
now.
No, sir. Share screen.
No,
करा. Share screen.
It is showing actually. Stop screening.
शेअर स्क्रीन केल्यावरती त्याच्यावरती एक ऑप्शन येते बघा, शेअर स्क्रीन असं, आणि त्याच्यानंतर मग त्याच्यात क्लिक करायचं आणि क्लिक केल्यानंतर मग शेअर.
Your entire screen or
एंटायर स्क्रीन.
It is coming? No,
Not,
no, not coming.
no, sir. No,
Not
sir.
coming, sir.
Not coming.
हॅलो. हा तिथून हे दिलंय का, परमिशन दिली का शेअर स्क्रीनला ते पहा, कारण माझ्या इथून शेअर होते. हॅलो. हॅलो.
Sir, permission not required.
हा माझ्या इथून
Already
शेअर होते,
guests
तिथून
are having
परमिशन नाही का?
permission to share the screen.
शेअर स्क्रीन आहे इथं. शेअर स्क्रीन केल्यानंतर युअर एंटायर स्क्रीन. हा
Yes.
एंटायर स्क्रीन. हा शेअर झाले का?
नाही झालं, सर.
शेअरिंग युअर स्क्रीन इथं देत आहे. stream.com is sharing your screen and audio असं येत आहे, पण का नाही?
Sir, 1 minute. Technical. 1 minute.
One day, sir.
One day, sir. बघ check कर.
Actually here it is coming. It is sharing your screen and audio. It is not coming.
It's not coming, sir.
Not coming.
Sir, one day, sir, is checking the problem. Technical. 1 minute.
Yeah. Because if shall I stop and again share?
Yes, sir. You can start and then afterward you can share the screen. If you
Just start introductory part, then then later
Okay.
we'll
Okay.
share.
Okay. I will like to thank Principal Kanse and Professor Nade and all other professor, committee member professor for inviting me in this lecture, this webinar. And I will like to congratulate Principal Kanse for his best principal award. Yeah, it is a very prestigious award actually. Okay, as you know, today is the Ozone Day, and this day is celebrated to just highlight the importance of this ozone layer, which is protecting us from these ultraviolet radiations. Of course, my topic is not tropospheric ozone, which is a very useful and helpful for our life. But I will be talking about tropospheric ozone, which is harmful. Actually, not only harmful for our health, but it is also harmful for our ecosystem or our environment, because it is a very effective or efficient greenhouse gas, and it helps or it helps for global warming actually. And if it is in the troposphere, it reaction or it efficiency for global warming is very high, and therefore it helps for increase in temperature over the globe. Of course, about this tropospheric ozone, Dr. Suvarna ma'am will tell you about that. That is a very important layer. But at the same time, I feel that if you are celebrating or we are giving importance of its useful effect of this ozone layer, same time how it is harmful, that also we should know. And specifically this lightning and its effect is very important actually, because lightning, as we know, it is a show very good correlation, or it is a very good response to the temperature, and therefore with global warming lightning is increasing, and increase in lightning will increase the ozone like greenhouse gases, and then it will again help or give the positive feedback for the global warming. It is a very important topic about this climate change. Nowadays, lightning they have recognized as one of the parameter for this climate change, and therefore its effect on ozone layer should be studied, because see, even though we have our country is a tropical country and large number of lightning and thunderstorms are happening, but still there is a very few people are doing, or there is a very few research people are doing on this topic, lightning, how lightning is affecting on this atmospheric chemistry, because lightning, as everybody know, it is a very energetic discharge. Actually, it can its energy is very huge. Therefore, it affects upon atmospheric chemistry. And the effect of lightning on atmospheric chemistry, it is not studied, at least in India, in a large scale. Therefore, and nowadays, as Professor Nade told, actually we have established this lightning network over India, and now we have this lightning data is available. And therefore, I think many people or some people should take this as a research topic, specifically from university or college level. People should take this research, how this lightning is affecting on chemistry, atmospheric chemistry. It is a interesting topic to be studied or doing research. Okay, it is still not coming.
Yes, sir.
Yeah, it is.
You can share it only. That screen is looking, but again it's gone.
If this screen is coming,
No, sir.
okay.
No, sir. Right now it's not. Yes, it's coming. Yeah. Yes, sir.
Now it is coming. Okay,
Yes, sir.
can
Yes,
you
sir.
see?
Yes, sir.
Okay.
Yes, sir.
Okay, then as I told, actually this is a tropospheric ozone is an important greenhouse gas and air pollutant which is harmful to human as well as ecosystem health. And as I told, this tropospheric or ground level ozone is not emitted directly into the air, but it is created by chemical reaction between oxides and NOx actually. Then I will talk about lightning. As I told, lightning is a very energetic discharge, and therefore it is producing affecting on atmospheric chemistry. But it is not directly involved in ozone formation, but it is a key source of NOx. Actually, it produces because of very high temperature generated in the lightning channel. The NOx get generated from generated by these lightning discharges, and that help to form the O3. Therefore, many people have observed that around the thunderstorm or during the thunderstorm, NOx also get generated, and it is increases, its concentration increases many times, many folds. People have observed the increase in ozone and NOx during thunderstorm. And of course, this lightning produced NOx is a very important contributor to the ozone and other trace gases. This understanding lightning produced NOx or nitrogen oxide and ozone formation in this region is important for determining the change in radiative flux resulting from change in ozone. Because as I told, ozone is a very efficient greenhouse gas, and therefore it affects on the radiative budget of the atmosphere. And therefore understanding this ozone and NOx production by lightning is a very important topic. And many studies, as I told, many studies have shown that lightning emission, lightning is affecting on many trace gases, including this ozone and NOx. And specifically this individual storm actually, because as I told, India is a tropical country and very severe thunderstorms are occurring here actually, and how this individual storms are affecting on this ozone production, it should be studied. Okay, first I will talk about the lightning, because since as Professor Nade told, I am working on this field since very long time. Therefore, first I will start with this lightning, how lightning can affect on the chemistry. Before that, we should understand what is the characteristics of lightning. As we know, actually lightning is an electrical discharge. Very famous kite experiment by Benjamin Franklin in somewhere in the 1750. Actually, he showed that lightning is an electrical phenomena. Earlier, people were thinking that, not knowing that how lightning is occurring. But the first time, Franklin showed that it is an electrical discharge. And for electrical discharge, actually two terminals should be there, because electrical discharge will occur if you bring two terminals of any battery close to each other, then there will be spark. It is called as an electrical discharge. Therefore, there is two terminals are required actually. And if you can see, this is a thunder cloud actually, and inside thunder cloud there are two charge regions. First is in this upper region. Here I have for schematic diagram I have plotted. Actually, you can see here actually this is the upper region. There is a positive charge region, and there is a negative charge somewhere in the middle or lower region, and they are very strong actually. As I told just now, that to produce the spark, even 1 millimeter or 2 millimeter, you require thousands of volt. And these two charge region, they are separated by few kilometers, at least 3-4 kilometers, and produce an electrical spark between such a long distance, 3 to 4 kilometer distance. Very huge electrical power is required. The potential difference between these two regions can be as high as 10 to the power 10 volt or 10 to the power 9 volt. Such a large potential difference only can generate the spark here actually. And this spark means electrical discharge between this positive charge region and negative charge region, that is called as the intra-cloud discharges. You can see actually many times inside cloud, you can see many discharges or many lightnings are happening. That is this type of discharges actually, intra-cloud discharges. And similarly, there is a discharge between this lower negative charge region and earth surface. That is called as a cloud to ground discharges, and they are very harmful for considering the lightning deaths and that thing. But these discharges, both the discharges, are specifically these intra-cloud discharges, are very useful or very effective in affecting on the atmospheric chemistry or production of NOx and ozone. This is mostly involved. Then just lightning characters I will just mention here. Actually, current flowing is a very high actually. You can see here 20,000 to 2 lakh ampere current flow during lightning discharge. This is a very high current actually. And second thing, you can see actually energy of flash is very high. It is 10 to the power 9 to the 10 to the power 10 joule actually. If you convert it into the energy what we are spending for this household, this electrical energy, at least 6 months in one lightning discharge can provide 6 month energy for a single house. This it is a very huge energy actually. And this is the important actually heating, because as we know, any current is flowing through any resistor, the heat energy will get generated. And by Joule's law, that channel from where lightning is occurring gets heated up actually. That heating that can go up to 80,000 to 30,000 degrees Celsius. And that is a very huge actually, because yes, you will be knowing that surface of the sun can have a temperature around 6,000 degrees Celsius. Means this is 4 times more than what the surface of sun is having. And therefore that temperature, the air column get expanded actually, and the shock wave get generated. That is what we call, or we hear it as a thunder. And that degree temperature means this temperature is a way this many chemical reaction it helps to form, and therefore this trace gases formation will occur. As I told, there are intra-cloud discharges, cloud to ground discharges, and there are some cloud to ionosphere discharges also. All these discharges help to produce the NOx and ozone. These are actually inside cloud. You can see how lightning occurs. First lightning start here. then there is a cloud to ground discharges, then if there is a second cell is forming here, and then intra-cloud discharges also will be there. So many types of lightning you can see here actually. This is the photograph of lightning. And now I will tell this how, what is the climatology of lightning or Indian region. Here actually I have shown the global lightning distribution, and you can see very clearly actually this is our India. And in Indian region also lightning activity is very high actually. These are the African region and this is South America and North America. These are actually considered as a very hot spot for lightning. It's very huge lightning is observed in that region. But if you see carefully, because this is the data from satellite, this Indian region, specifically this North India and Northeastern India and this Himalayan foothills of Himalaya, lightning activity is almost comparable with this all other parts of the world. And therefore huge lightning activity you can see, especially this southern India also and this North India also, very high lightning activity is observed. Uh, Here actually we have from 20 years of satellite data, we can see very clearly actually this most part of the India there is a lightning activity, specifically this foothill of Himalaya, and this is actually pre-monsoon season and this is monsoon season, and both the season high lightning activity can be seen over Indian region. Then as I told actually this is a lightning they have considered, or nowadays they are included as one of the climate change parameter, because lightning show very high response to the temperature change. If temperature is changing by 1 degree, people have observed almost 10% change in or increase in lightning activity. And you can also see here actually, as I shown this figure also, this lightning is very high in this tropical belt, because temperature is very high there actually. Even you can see this diurnal variation. Diurnal variation actually it is plotted in UTC, universal time. Therefore you have to add 5.5 hours in this scale. Therefore you can see this peak or lightning activity is maximum during afternoon hours when the temperature, surface temperature is very high. This is for 2 years we have plotted. And even similarly you can see the annual variation, that lightning is very high during May and June when the temperature is highest, or surface heating will be more there. And again you can see this September and October, again after monsoon withdrawal, heating will take place, and then again lightning is increasing. That means lightning show very good response to the temperature. When temperature is increasing, lightning also increases. And as I told, therefore it is very important to monitor this lightning and ozone relationship, because lightning is increasing, as I told, it will increase the ozone production also, and ozone, if it is a good greenhouse gas, then it will again help for the temperature increase. Means it is giving a positive feedback to the climate change. Here also you can see actually lightning and precipitation both are showing, means capes specifically show very good increase in trend over Indian region. Here also you can see actually lightning and cape both are showing very good increasing trend. This lightning during monsoon also shows very increasing trend. That means whatever this global warming or whatever climate change is happening, it is definitely showing that lightning frequency or lightning thunderstorm frequency is increasing, and because of that is it is becoming very important to study its effect on atmospheric chemistry. So then similarly lightning is increasing because of this urbanization effect. Actually urbanization, as there are two aspects of urbanization. First is actually removal of vegetation. If you remove the vegetation, that cities will act as a island. Actually, as I have shown here, actually this is an island in the sea, and as we know the heat capacity of water is very high compared to land. Therefore water will not get heated up, but the land will get heated up, and therefore convection will start there actually, and convection will increase. The same things are happening over many big cities. Actually big cities are, we are removing vegetation. Therefore they act as an island, and therefore because of this heat island effect, convections are increasing over many big cities actually. And there are aerosol effect. Aerosol also is helping to form the or increase the lightning activity. You can see actually if it is a boundary layer is clean, then there will be bigger drops actually, and because lightning activity is will happen above 0 degrees Celsius only, because to get charge separated or charge generated inside thundercloud, it requires ice particles of different sizes. If bigger ice particle collide with the smaller ice particle, then the charge separation will take place. Therefore, that thing happen in this mixed phase region actually. Above 0 degrees Celsius only that charge generation or charge separation process will occur. And if there is a clean boundary layer, then these water droplets will not go above 0 degree, and therefore there is no much lightning or electrification will occur. Actually, you also might maybe noticed actually over ocean there is no much lightning activity because there is no much aerosols over oceans. But if you see the actually over a land surface, if there are polluted boundary layer or there are aerosols, then the droplets will be smaller actually. Small droplets will form, and because of the updraft or buoyancy, they will get transported into this above 0 degree level. And then this electrification will start and lightning will start. Therefore, this aerosol and earlier as I shown heat island effect, these both effects are increasing the lightning activity over most part of the world. Therefore, lightning activity is increasing actually, and here also we have plotted over big cities actually. We can see Bangalore and Delhi I have plotted, and lightning activity as well as rainfall both are showing very increasing trend. Then, as I told, inside cloud there are two main charge regions, and mostly lightning discharge is the main discharge. But with that, actually, there are some discharges which also help for this atmospheric chemistry. Because that discharges, as I told, lightning discharge can generate a heat, very huge heat actually, and therefore this help for this uh, chemical reactions. Similarly, there are corona discharges actually, as I have shown here actually. This is a thunder cloud, and if there are some trees or raised objects, then electric field at this raised object will get converged actually, and therefore because of a huge electric field here, there are some small discharges. They are called as a corona discharges that also will occur along these tips of the raised objects, specifically trees or some electrical poles. There will be huge electric, I mean small, it will be discharges we cannot see by our eyes, but they will be happening, and they will also create they will also help for these chemical reactions, because that there also heat will get generated. Then there is inside thundercloud also, even though this electrical discharge means lightning, other than lightning discharges, there are some small discharges. Just like I told here, there inside cloud also there are some particles, means water droplets and ice crystals. On the sharp edges of wire, there are also some small corona discharges type of discharges will be occurring, and they also will produce a large heat, and that heat also help for these chemical reactions. Therefore, this not only lightning discharges, but these small discharges also people have observed they are affecting on the chemical properties of the atmosphere. Atmospheric chemistry, they are also having some effects. Therefore, all these three effects we should see. Okay, then I will, means we did some study of this effect of lightning activity on surface NOx and O3 over Maharashtra, because as I told, this lightning network we have established over Maharashtra during this 2014. Then that 5-6 years data, we studied how this lightning activity is affecting on surface NOx and O3. Here actually you can see I have plotted the lightning. It is actually number of flashes, and here also we can see actually May and June, these 2 months lightning activity is very high. Again we are getting one peak in September, August and September, when withdrawal of monsoon start, that time also we are getting. And this is actually NOx and tropospheric ozone. Actually, this is measured satellite measurement. we have taken for that Maharashtra region only, and we can see actually here also we are getting ozone concentration is high during May and June, and similarly we are getting this is April, May and June, but we can see actually this April also it is showing very high because ozone formation requires some sunlight also very high heating, and therefore April, May, and specifically this lightning also is showing contribution of lightning also we can see very clearly actually, and then again September, October also it shows the increase in NOx and O3. Here you can see very clearly actually, as I told, this lightning is directly affecting on this NOx or nitrogen dioxide, and it is an indirect effect. Therefore, this relationship between lightning and NOx is very robust actually. You can see wherever there is an increase in lightning, NOx also is increasing. And similarly, it shows, definitely it shows the response in O3 also, tropospheric ozone also show increasing uh, relationship with this lightning. But it is not as robust as O3 because there are other sources of ozone also, biomass burning and other things. Here you can see actually this correlation is good actually here. This correlation is little less, but still this is a significant correlation you can see actually between tropospheric ozone and lightning flashes. And these both are showing very good correlation between these two parameters. Therefore, this our study, it was published in 2017. Actually, this tropospheric low and lightning follow well-defined seasonal cycle with peak in pre-monsoon and deep in monsoon season over study region. Of course, this pre-monsoon and monsoon lightning and all these are matching actually. This when lightning is increasing, NOx and O3 also showing the increasing trend. Then this study clearly suggests that lightning activity play important role in formation of tropospheric O3 and NO2 over Maharashtra during pre-monsoon and monsoon and even post-monsoon season. Therefore, this is a very means even though as I have shown actually here, even though it is showing very good correlation, but it is a only 3-4 year study we have done. Now we have more data and we can even study more clear with more data this phenomenon. Then actually here we studied using lighting network data over Maharashtra. But this we have in IITM, we have atmospheric electricity observatory, and since long time we are taking the measurement of electric field and so many parameters during thunderstorms. And similarly, this NOx and O3 also measurement over Pune region is doing by this atmospheric electricity, atmospheric chemistry group. Therefore, we analyzed how this surface measurement, it is a surface measurement, means how this lightning is affecting on the surface values of NOx and O3. And these are the instrument to, of course, surface electric field using field mills and other things we measured. And these are the ozone and NOx measurement. This is actually one thunderstorm on 3rd May 2005. Here we have plotted this lightning flash rate, and this is the electric field. We can see this is the active phase of thunderstorm, and it is started dissipating. Actually, this is the dissipation stage of thunderstorm. And if you see here actually, because here you can see actually this is the thunderstorm period actually. This is the thunderstorm onset, this is the active thunderstorm, and this is the dissipation, means dissipation of thunderstorm started here actually. This is the active period of thunderstorm. And we can see actually during active phase there is no change in NOx, or I will talk about ozone later. But if you see the NO2 measurements, NOx measurement, you can see actually there is no change. Mainly because as I told, this NOx formation is happening inside cloud actually, and when the thunderstorm is happening, there is a updraft velocity or there is a vertical air motion, and therefore that NOx is remaining in the upper atmosphere only. It is not coming down. But when dissipation stage start actually here, you can see it is a starting of dissipation stage. This increase in NOx can be seen because during dissipation stage there is a down drop will start. There will be downward motion of air, and with that downward motion, that NOx formed in the upper atmosphere that starts coming down, and you can see it has increased very high. Actually, here it is around 3 to 4. It has gone up to above almost 12, about 12 it has gone actually. Means it has very high, huge increase it has observed. But actually, if you see here, actually, ozone is showing decreasing trend. Means it is not increasing with at the surface, ozone concentration not showing increasing trend, mainly because here actually this increase in NOx is very high actually. If increase in NOx is about 12 ppb, then it will act as a reducing agent. Means it will reduce the ozone formation, or it will destruct. Means it will destroy the ozone, and therefore we can see actually during this period ozone has destroyed. Actually, ozone has come down. Similarly, here also you can see actually another pre-monsoon thunderstorm we have here also 2008, and here we can see here also during dissipation stage very huge change in NOx you can observe. Actually, it is more than 12 it has gone, and here also you can see very clearly it is helping for a destruction of this ozone. When it is increasing, you can see very clearly actually if it is going around about 12, then the destruction of ozone can be seen very clearly. It is destroying, it is reducing the concentration of ozone when NOx is very high. It can be seen very clearly here actually. But you can see here actually there is a during monsoon another thunderstorm. Here also you can see this flash density is very high. But you can see here actually here this during dissipation stage NOx has increased. But you can see very clearly actually it has not gone about 10. It is a very small, and in that case ozone show significant increase. Means if the NOx is not very high, then it show means it will not reduce, but it will help the formation of ozone. And we can see very clearly in this case. In this case, the NOx is increasing. The similarly, this ozone also is increasing, and this also you can very clear actually. There is during monsoon, even though thunderstorms are very high, they are not transporting much NOx to the surface. It is mostly because monsoon time there is a vertical motion all over the atmosphere. Therefore, most of the NOx that is getting transported to the upper troposphere. It is not coming to the surface. This observation saw many-fold increase in NOx because, as I told, this many times we have shown even 7 times or even more than 70 times. Sometimes it has gone to 70 times increase in NOx during dissipation stage of thunderstorm. And a large amount of fresh NOx do not immediately contribute to photochemical ozone production and can lead to ozone decrease by both direct titration and nighttime chemistry, because most of the time these thunderstorms are occurring in the evening time, and therefore dissipation stage will come when it will start the after sunset, and therefore this nighttime chemistry also is affecting on that. Okay, thank you very much. That much was only I have prepared. Okay, if there is some questions, you can. Hello, can you hear me? Okay, please on your mic. Mic is muted.
Thank you, sir.
Okay. Okay, if there is any questions, I can.
वन डे सर कुठे गायब झाले वाटतं. हे कोणतरी वन डे सर सांगा जरा. वन डे सर असणे चालू कर म्हणा.
Okay.
हे चालू कर ना वन डे सर काय.
Okay.
हॅलो सर. ओके.
Okay. About I think
Thank you,
this.
sir. Sorry for technical error.
Okay.
Few questions
Some
have
questions.
asked by the students and participants. Yes, I would like to ask.
Okay, this
Yes, can you hear me?
question, I think Swarna ma'am will answer because I don't have long-term variation. I have not studied. So can you?
One more question, sir. I would like to ask you. How this tropical ozone, which is created by the lightning activity, how that ozone can affect on our life? Is it
Yeah,
affect on
yeah,
our life, or it will
yeah,
be?
yeah. That's what I told. Actually, it is affecting our
That is
health
question.
because it is a air pollutant. It will affect on many our health problems. And similarly, it will affect on our health of
Yeah.
our ecosystem or environment because it is a greenhouse gas. Therefore, it is helping for this global warming. Therefore, it is affecting on opposite way. Means it is not helping, but it is harmful in the troposphere because it is affecting our health as well as
It's affect on
global
your.
warming. Yes, yes. It is a pollutant. It is a
Yes.
air pollutant actually.
Yeah. One more question asked by the Omkar Patil. We observe the large number of lightning even in post-monsoon time, but we know that the concentration of aerosol is settled down in the monsoon time.
Actually, it is not exactly true because last year some two students from Kolhapur, Kodavati University did a project with me, and we studied the aerosol concentration, yearly concentration over Kolhapur and over Maharashtra also, and definitely we can see actually because monsoon it is coming down, but immediately after post-monsoon aerosol is increasing. And of course, aerosol is not the only factor affecting on the lightning formation because moisture content, instability, other factors also is very important. And during post-monsoon, moisture content is very high, and as well as I told, the heating will start, and that will create large, that will create large instability. Therefore, lightning is mainly because of that instability and moisture content. Of course, aerosol also will be there, but they are not very high as you are telling. Okay. Then as somebody was asking about this artificial, 1 minute. Hello. एक वेबिनार मध्ये मी करतो. Artificial creation of ozone is almost not possible. As I told, lightning and that very high energy discharges are required. Or even Swarna ma'am can tell more about this actually. But artificial formation of ozone, I have not seen any time.
Okay. So thank you, sir. Thank you very much for a nice, nice and very informative this lecture. So many comments are there. So many participants have written there is nice information, like that message is there. On behalf of this institute, I would like to say thank you very much, sir, for giving this wonderful lecture. And definitely, whenever will this COVID-19 will be finished, then we will connect face to face, and you will be here at our campus definitely in the next few days. Thank you, sir. Thank you very much. Now we move to the next session, and I would like to our colleague, Mr. Natya sir. He will introduce to our next guest, Dr. Fadnavis ma'am. Nandakumar, please continue.
Good afternoon to all. I'm here to introduce Dr. Srimati S. Fadnavis ma'am. They are working as scientist in Indian Institute of Tropical Meteorology, Pune. They have completed their Bachelor of Electronics from Nagpur University, then MTech from Pune University, and they have completed their PhD from Pune University in the atmospheric physics. Madam has several research papers, and their main research interest is in atmospheric chemistry and dynamics, upper troposphere and lower stratosphere interaction with monsoon, stratospheric process and chemistry, mesosphere temperature, trends and inversion. They have several awards, and few of them are, they are the member expert in the field, which was the awarded by scientific for this steering group SSG for tropospheric sulfur and its role in climate change. And then they have awarded by WMO's International Nobel Garbier Mum Award, which was awarded by WMO, that is World Meteorological Organization, for their best research paper in 2005. She has started her career as senior scientific assistant. Then she has worked as junior scientific officer in IITM Pune, and then they have scientist B, scientist C, and scientist D, and currently they are working as scientist F in IITM Pune. They have several research papers, more than 61, and they have several honors and awards, in which Dr. Suvarna S. Fadnavis ma'am was selected for top authors and was invited to attend top authors reception during fall meeting of AGU on 16 December 2010 at San Francisco for their articles to be published in Earth Science journals. They have research paper entitled Mesospheric Inversion Layer and Spirits, published in Journal of Geophysical Research. And then the research paper entitled Seasonal Variation of Mesospheric Inversion Layer, Thunderstorm and Ozone over India, which was published in Geophysical Research. and has been selected for editor's choice in atmospheric and space electricity. It is also cited at second topmost research paper on worldwide science. Then they have several national and international collaborations, in which one is Indo-German collaboration for the project Effect of Asian Summer Monsoon ASM on the Upper Troposphere, Lower Stratosphere UTLS. And then they have the project High Altitude Measurements using Balloon Suit, collaboration between Indian Institute of Tropical Meteorology Pune and the ETH Zurich, Switzerland. Then they have several research projects sponsored by Indian Space Research Organization, mainly known as ISRO from Bangalore. And they have several academic activities. They have taught to MTech for the atmospheric sciences to the students at University of Pune in since 2005. Then they have delivered several lectures in the computational methods during 2004 at IITM Pune. This is the brief introduction to Dr. S. Fadnavis ma'am, and I request ma'am to deliver their talk. Ma'am. Ma'am, your mic is off.
You should unmute your mic. Ma'am, yes.
So thank you, Dr. Nate, for nice introduction. So today, I first introduce myself. I'm Dr. Fadnavis, a scientist on atmospheric chemistry and climate change. This is my research topic, and I work in the Center for Climate Change Research, Indian Institute of Tropical Meteorology, Pune, in India. Today, on occasion of World Ozone Day, being celebrated at Bharati Vidyapeeth, Dr. Patangrao Kadam Mahavidyalaya, Sangli, I talk on ozone for life. I will present some of my latest research on ozone layer in the stratosphere, which protect the life on the earth. So before I proceed, I thank Dr. D.G. Kanse, Principal and Chairman, for inviting me for this talk, and I also congratulate him for the Best Principal Award. I also thank Dr. C. Patil, Convener, Dr. P. M. Patil, in charge, Society Faculty, Dr. Dada Nade, for contacting me and arranging this talk today. I also thank Dr. Nate, Dr. Suple, and Vande for making all the arrangements. So I proceed. Some brief introduction before going to research. So word ozone, it comes from the Greek word ozine. It means to smell, since ozone has pungent odor. It is discovered in 1839 by Professor Solbin at University of Basel in Switzerland. Ozone is highly reactive gas, and it is composed of 3 atoms of oxygen. It is naturally occurring in the stratosphere. I will explain this a little later, but in the troposphere, it is produced due to man-made activities. Ozone in the troposphere is also produced naturally during lightning, as explained by my colleague Dr. Pawar. Ozone affects the life on the earth in either good ways and bad ways. Ozone in the troposphere produces a bad impact on human health and vegetation, hence it is considered as a bad ozone, while ozone which exists in the stratosphere is considered as a good ozone because it saves the life on the earth. So whole atmosphere is divided into different layers. The layer of the atmosphere near the surface where we live is known as troposphere. Above that is the stratosphere, then mesosphere and ionosphere. So ozone layer exists in the stratosphere and mostly concentrated around 25 km. Here we can see this pink color line shows the ozone layer in the atmosphere. It covers whole the globe and is mostly occurred between 16 to around 28 km in the lower stratosphere. Ozone also exists in the troposphere and mesosphere, but in a very small quantity. Ozone in the troposphere is a pollutant and is hazardous to our health. Total ozone in the atmosphere is mostly concentrated, around 90% of the ozone is concentrated in the stratosphere, in the ozone layer, and remaining is distributed in the troposphere and stratosphere. So, how ozone layer is formed and how it is maintained, it is explained by a scientist, a British scientist, Sidney Chapman. He explained this ozone layer in 1930. As per this Chapman mechanism, when ultraviolet radiations having wavelength less than 240 nanometer collide on the oxygen molecule, it dissociates and forms oxygen radical. This oxygen radical, once formed, again it combines with the oxygen molecule in presence of third body and forms ozone. Ozone, once formed, again react with the oxygen radical and dissociate and form ozone molecule, oxygen molecule. Ozone also dissociate by the photons and to form oxygen molecule and oxygen radical. So ozone continuously form and dissociate. But then how ozone layer is maintained? This is because ozone formation rate, the rate of reaction of formation of ozone is faster than its dissociation. Thus, ozone layer is formed naturally in the stratosphere around 25 kilometers where it is mostly concentrated. So, ozone, why it is formed only in the stratosphere, why not in the troposphere and mesosphere? This is because the wavelength which dissociate the oxygen molecule, that is wavelength less than 240 nanometer, these wavelengths are available only in the stratosphere. That is why ozone layer is formed in the stratosphere here, where lambda less than 240 nanometer is available. It is naturally formed and maintained there. Formation of ozone and dissociation is taking place from millions of years on the Earth. And research show that the ozone layer thickness changes with time. Ozone layer has self-regenerating ability. This is because oxygen is constantly supplied into the atmosphere, and when wavelengths less than 240 nanometer collide on this, it forms ozone, and thus ozone which is destroyed is again produced through this oxygen molecules. Thus ozone layer has self-regenerating ability. We know that ozone layer protects us from harmful ultraviolet radiations. Ultraviolet radiations has wavelength between 100 to 400 nanometer. It is further divided into three categories: UVA, UVB, and UVC. UVA has wavelength between 320 to 400 nanometer, B between 290 to 320, and C has wavelength between 290 to 100 nanometer. So here we show their absorption in by the ozone layer, and this yellow color line shows the ozone layer. It peaks around 25 kilometer here, we can see that, and this red color line shows the tropopause, and atmosphere below is troposphere. So ozone layer in the stratosphere here, and we see that UVC radiations which are coming from the sun are fully absorbed by the ozone layer, and they do not penetrate down in the troposphere, and we are protected from very harmful UVC radiations. UVB radiations are partly absorbed by the ozone layer, and partly they penetrate into the troposphere, and they cause harm to us. They cause skin cancer, eye irritation, and many other harmful effects. UVA radiations mostly penetrate through the ozone layer, and they reach the surface and troposphere, and they reach to us, but they cause very less harm. So ozone layer plays an important role protecting us from UVC and UVB radiations. So we have seen that ozone in the stratosphere is naturally formed, but this is not the case for the ozone in the troposphere. So what happened in the troposphere? There are some pollutant gases such as NOx, called nitrogen oxide, carbon monoxide, and volatile organic compound, abbreviated as VOCs. So these pollutant gases, when they react in presence of sunlight, they form ozone. So ozone is formed into the troposphere, therefore it is called a secondary pollutant. The gases which play a role in formation of ozone are called ozone precursor gases. So main precursor gases are NOx, carbon monoxide, and volatile organic compounds. study shows that they are emitted from the vehicular emission, industrial emission, biomass burning activities, which are mainly because of the human activities. So our human activity cause increasing amount of NOx, CO, and volatile organic compound in the troposphere. And study shows that over the period, more and more industrialization is occurring over the Indian region. Number of vehicles are increasing, and more anthropogenic activities are occurring because of large population over the Indian region. So these pollutants show increasing amount in the troposphere, which leads to more formation of ozone, and ozone in the troposphere has hazardous effect on human health and plants. Here we see that increasing amount of ozone makes it difficult to breathe us deeply and vigorously. Ozone, high amount of ozone in the troposphere aggravate the lung diseases such as asthma, chronic bronchitis, etc. Ozone also damages the plant. It damages the plant physiology. Whole canopy and root system processes are damaged by the ozone, and it reduces the crop yield. Thus, ozone in the troposphere is not good for the human, also for the plants. But unfortunately, the ozone in the troposphere shows increasing trend. This is a figure shows trends in tropospheric ozone over the Indian. Here is Indian region. This is plotted from the satellite measurement, MLS and OMI, and this is from the model simulation MIRA-2. We see that ozone shows increasing trend over the Indian tropospheric ozone basically show increasing trend over the Indian region, and it is increasing at the rate of 2 to 3 dioxide unit per year during 2005 to 2016, which is the latest years, and it indicates that increasing ozone means there is increasing NOx and increasing VOCs, which are producing ozone here. Hello? Yeah? Is there an issue? Huh? I have shared it. Hello? Shall I log out again? I have done that. I will stop sharing. Is it okay? Can you see me? Screen the screen. Can you see now? Can you see the screen? Hello?
Hello. Hello.
Can you see now? Yeah.
Yes, ma'am. You will continue. Screen पण दिसते, तुम्ही पण show होत आहे.
Is it okay now?
Yes, ma'am. Just open your presentation in full screen mode.
Can you see now?
Yes, ma'am.
What happened? From where should I start? From the beginning?
No, where you are. You just open your presentation with full screen.
Yeah, but I should start from the beginning where I lost the connection. I don't know.
No, ma'am. You will continue from here. Your voice is audible at that time also. No problem.
Okay.
Okay, ma'am. Thank you.
So, increasing ozone pollutants such as NOx and VOC points to increasing ozone, and there is significant increasing ozone in the over the Indian region, which points to increasing NOx and VOCs over the Indian region. These ozone pollutants which are emitted at the surface not only increases the tropospheric ozone, but recent research shows that they are transported up by the monsoon convection, and they are injected into the stratosphere and then damages the ozone layer in the stratosphere. So NOx and VOCs which are emitted are lifted up by the monsoon cloud and then injected. This red line is tropopause, and injected above tropopause into the lower stratosphere. And then it damages the ozone layer here. Ozone reduction also causes when there is a tropopause fold. So it. Hello. It is full screen mode only. Few minutes ago it was okay. Now what happened? It is on a full screen mode only. I don't know. What should I do? Screen sharing I did. Then I said share screen. Then application window I did. Then I have clicked here. I say share. Now I will keep my this thing, and my presentation is in the full screen. Now is it okay? Can you see my presentation? ओपन ही है, फुल मोड में है ऑन द स्क्रीन. हाँ हाँ हाँ. What can you see on the screen? Okay, I have stopped the sharing. Now I said share screen. And then your entire screen or application window. Okay, it is not clickable. My entire screen is not clickable. Okay, now it is there. And shall I open my PPT? And if I make it full, can you see it now? Okay, okay. I think I'll start from the beginning. Okay. So thank you. So sorry for this all technical issues. Okay, now I start from the beginning. The word ozone comes from the Greek word ozine, means to smell, and it has a pungent odor. It is discovered in 1983 by Professor Sobin at University of Switzerland. Here we show the structure of the atmosphere. The layer of the atmosphere near the surface where we live is called troposphere, and above that is stratosphere. Above the stratosphere is mesosphere, and above mesosphere is thermosphere. So ozone layer exists in the stratosphere near 25 km. This pink color line shows the ozone layer, and it is mostly concentrated around 25 km in the stratosphere. Around 90% of total ozone in the atmosphere is concentrated in the ozone layer here, and very few amount of ozone is present in the troposphere and mesosphere. Ozone which is present in the troposphere is harmful to us and makes it produce a hazardous effect on the human health and crop. So Chapman has explained the mechanism for formation of ozone layer in the stratosphere here, which exists here. He is a British scientist from Sydney, and Chapman. He discovered this ozone layer in 1930, and he explained this mechanism as when solar ultraviolet radiations having wavelength less than 240 nanometer collide on the oxygen molecule, it dissociates the oxygen molecule to form atomic oxygen or oxygen radical. Oxygen radical then react with the oxygen molecule in presence of third body and to produce ozone. Ozone, once produced, it again react with the oxygen radical and dissociate to form oxygen molecule. Ozone also dissociate by the photons to produce oxygen molecule and oxygen radical. Thus, ozone is constantly formed and dissociated in the atmosphere. But rate of formation of ozone is much higher than its dissociation. That is why ozone layer is maintained in the stratosphere. This layer is formed only in the stratosphere because the wavelengths which causes dissociation of oxygen molecule are available in the stratosphere only. Thus, ozone layer is formed naturally in the stratosphere, and this layer is formation and dissociation of ozone constantly occurring in the atmosphere from millions of years, and research show that thickness of the ozone layer varies with time. Ozone layer has self-regenerating ability since oxygen molecules are constantly introduced into the atmosphere, which dissociate and form ozone layer. Ozone layer plays an important role in protecting us from harmful ultraviolet radiations. So here this diagram which shows that how absorption of UV radiation takes place by the ozone layer. This yellow color line shows the ozone layer which peaks around 25 km here, and we can see that UVC radiations are fully absorbed by the ozone layer. They do not penetrate down into the troposphere and reach up to us, while UVB radiations are partly absorbed by the ozone layer and partly they penetrate deep into the troposphere and cause harmful effect to us such as skin cancer, eye irritation and many others. Thus, ozone layer protects us from UVC and UVB radiations, but UVA radiations are penetrated through ozone layer and they reach into the troposphere up to us, but they do not cause many harmful effects. Thus, ozone layer plays an important role protecting us from harmful ultraviolet radiations. Ozone in the troposphere is not naturally found as or formed as in the stratosphere. But in the troposphere, ozone is produced because of some pollutant gases. When they react in presence of sunlight, they produce ozone. These gases are nitrogen oxides, carbon monoxide, volatile organic compounds. When these NOx, carbon monoxide and volatile organic compounds, they are emitted in the troposphere mainly because of anthropogenic activities such as vehicular emission, industrial emission, biomass burning, and other man-made activities. So, research shows that over the India, population density is increasing, industrialization is increasing, more use of vehicle is being taking place, which emit large amount of this ozone producing gases such as NOx, carbon monoxide and volatile organic compound, and leads to more ozone production in the troposphere. And it is harmful to us, and not only to us, also to the plant. Ozone in the troposphere makes a difficulty in breathing. It makes deep breathing and make it difficult to make us deep breathing and vigorous breathing. Ozone also aggravates lung diseases such as asthma, chronic bronchitis. Ozone cause injuries to the crop and plant. They affect plant physiological processes from canopy to root system processes, all processes, and it reduces the crop production. Unfortunately, this ozone, which is not harmful to us, to human being and plant, is increasing over the Indian region. This is the schematic plotted from the satellite measurement and model simulation, and it shows that ozone over the Indian, this is India here, and ozone, tropospheric ozone over the Indian region shows increasing trend. It is increasing at the rate of 2 to 3 dioxin unit per year during 2005 to 2016. This points to increasing NOx, volatile organic compound, and carbon monoxide over the Indian region, and create a lot of ozone production over the Indian region. This not only affects the tropospheric ozone, but it also affects the stratospheric ozone layer. This NOx, volatile organic compound, which are produced at the surface, near the boundary layer are lifted up by the monsoon convection above the tropopause, and they enter into the lower stratosphere. This red color line shows the tropopause, and latest research showed that convective clouds lift these pollutants from the surface above the tropopause into the stratosphere, and once they enter into the stratosphere, they damages the ozone layer present here. Damaging of ozone layer here means introduction of more UVB and UVC radiations in the troposphere and causes damage to the human life. Ozone in the stratosphere also damages the troposphere when there is tropopause fold occurrence. When tropopause fold occur, it injects the stratospheric air mass into the troposphere. The stratospheric air mass contains large amount of ozone, and it is suddenly injected into the troposphere. Nearly 1/3 of the ozone in the troposphere is enhancement occurs because of the stratospheric intrusion. So sudden increasing ozone in the troposphere increases the ozone pollution in the troposphere and reduces the ozone in the stratosphere, both of which are not desirable. Reduction of ozone in the stratosphere means more increasing UV radiations, and increasing ozone in the troposphere means increasing pollution. So ozone transport in the troposphere is not desirable. Other processes which damages the ozone layer in the stratosphere are volcanoes. Volcanoes, when they erupt, they inject large amount of sulfur dioxide gas into the stratosphere. On its oxidation, it produces sulfate aerosols, which provide a surface for chemical reaction containing chlorine and bromine, which then cause destruction of ozone layer and causes thinning of the ozone layer. Other processes which affect the ozone in the stratosphere and troposphere are QBO, gravity wave braking, 11-year solar cycle, Rossby wave braking, etc. So this is our study where we show that tropopause fold occur over the northern Indian region, and it causes sudden intrusion of stratospheric ozone in the troposphere over the northern Indian region. We can see that this dotted black line is tropopause, and stratospheric ozone is injected through the tropopause into the upper troposphere and enhances tropospheric ozone, which is not desirable. And our study shows that these folds are frequently occurring during pre-monsoon time and less frequent during monsoon time, but they keep occurring over northern India and enhances ozone over the Indian region. Nearly 30% of ozone is enhanced in the troposphere due to tropopause fold. This is our another study where we show that this ozone air which coming from the stratosphere also affect the monsoon and rainfall over the Indian region. It causes decreasing rainfall, and decreasing rainfalls means scarcity of water over the Indian region. So here in this paper, first we provide a case study from 10 June to 18 June 2014, where we show that tropopause fold occur over the Indian region and which inject the stratospheric air mass into the troposphere over the northern Indian region. This is 25° north here, and it injects the ozone-rich air in the troposphere over the Indian region. This air mass comes from the stratosphere, and that is why it is quite dry. Stratosphere is drier than troposphere, so dry air intrusion occurs through tropopause fold. This black line shows the tropopause, and through this fold, stratospheric dry air intrusion occur over northern India in the troposphere. So dry air has implication on the monsoon circulation. Here we show that time versus vertical distribution of temperature anomaly, relative humidity, which indicates the dryness of the air, and stability of the atmosphere as indicated by anomalies in Brunt-Väisälä frequency. We have seen that tropopause fold occur on 10 June over the Indian region. So we can see that around 10 June, tropopause fold occurs, and then it injects the cold air mass from the stratosphere, which enter over the Indian region and remain in the upper troposphere till 28th of June. After this fold, the air mass coming from the stratosphere is quite dry, and this dry air mass remain over the Indian region for rest of the June month. We can see that relative humidity is significantly low. It has created stable atmosphere in upper and lower troposphere, and dry air, we know that it doesn't allow the cloud to grow. This cold air also suppresses the synoptic activity, means cloud formation activity, and rain processes. Thus, this ozone-rich cold and dry intrusion which occur over the Indian region suppresses the rainfall and leads to reduced rainfall over the Indian region. So it is very important to reduce the ozone precursor gases such as NOx and volatile organic compound, which causes decreasing rainfall over the Indian region. This is our another study where we see the impact of the NOx emission. Our previous study shows that ozone chemistry over the Indian region is mostly controlled by the NOx but not by the volatile organic compound. So what we do, we use a chemistry climate model to understand the impact of NOx emission on ozone production, heating rate and changes in the monsoon circulation. For this purpose, we make different simulations. In one simulation, we increase the NOx emission over India by 3.8% per year because this is a trend obtained from the satellite measurements. We then also understand what happens if NOx emission keep increasing and they become double than the present value, then what are its impact. So another simulation, we increase the NOx over Indian region, double that of the trend observed by the satellite. So this is distribution of NOx averaged over the Indian region, and we see that over the northern India at the southern slopes, this shows the Himalaya. From the southern slopes of Himalaya, there is increasing NOx complete in the tropospheric column, and this black line indicates the tropopause, and there is increasing NOx above the tropopause in the lower stratosphere. This is for the simulation where NOx are increased as per the satellite observed trends. But this is the simulation for doubling of the NOx over the Indian region, that of the satellite observed trend. Here we see some interesting result. We see that increasing NOx over Indian region increases here in the low troposphere, but increase does not occur in the low stratosphere above the tropopause here. These are ozone production rate, and we see that for normal increase, that is 3.8% per year, there is a high ozone production complete in the troposphere and in the low stratosphere. But when we double the NOx emission, that of the satellite observed trends, we see that there is a loss of ozone in the low stratosphere and eastern part of the Indian region. Our analysis show that significant increasing ozone increases ozone heating rate and which changes the monsoon circulation. This is distribution of vertical winds for increasing NOx by 3.8% over Indian region, and this is for the doubling of NOx. And we see that when we increase the NOx, which increases the ozone, and therefore it increases the ozone heating rate and increases the vertical motion over the Indian region, which allows more cloud to form, synoptic activity to occur, monsoon hardly circulation to strengthen, and it resulted in increasing rainfall over the Indian region. But when we double the NOx emission over the Indian region, it reduces the ozone in the upper troposphere and lower stratosphere and changes the monsoon circulation. And we see that instead of increasing vertical wind over northern India, there is downward wind over the northern Indian region. These downward winds suppresses the cloud formation processes and rain processes and resulted in decreasing rainfall over the Indian region. Thus, we say in this study, we say that it is very important to reduce the NOx emission, and it is okay to have the current emissions because it contributing to increasing NOx, but it should not increase further. It may increase the scarcity of water over the Indian region. So other than this NOx, VOC and volatile organic compound, there are some substances which are called ozone depleting substances which affect the ozone layer in the stratosphere. These ozone depleting substances mostly contains chlorine, bromine and carbon. They are called fluorocarbons, usually abbreviated as CFCs. Common man knows CFC better than chlorofluorocarbon. So CFCs mostly emitted from refrigerator, air conditioner, fire extinguisher and dry cleaning agents, electric equipment, agricultural fumes, etc. Other than CFC, halogens also cause ozone loss, and they are mostly emitted from the fire extinguishers. So these ozone depleting substances play a great role in decreasing ozone layer in the stratosphere, and ozone layer was depleting at a higher rate in the past. Therefore, Montreal Protocol was forced into existence. So treaty was signed by different all countries over the world, and this treaty was signed on 26th August 1987, and it was implemented on 26th January 1989. Under this treaty, it was agreed that to reduce the ozone depleting substances, which mostly few of them I have written here, which contains chlorofluorocarbon, carbon tetrachloride, methane chloroform, hydrofluorocarbons, etc. So this ozone depleting substances causes thinning of the ozone layer, and they also affect the ozone hole which form in the polar region. So what is ozone hole? It is not a hole where there is zero ozone present, but it is thinning of the ozone layer which present in the stratosphere. The thinning is such a to the extent that ozone amount in that ozone layer falls below 220 Dobson unit. Generally, ozone in the ozone layer has a value more than 300 Dobson unit. But when its value falls below 220 Dobson unit, it is called a ozone hole. So the area around the pole where ozone values are less than 220 Dobson unit is marked as a ozone hole. So every year ozone hole form in the northern and southern pole over Antarctic and Arctic region. Every year this ozone hole formed does not have same size and same amount of ozone, but it keeps varying. So we see that largest ozone hole was formed in 2000 and 2006 over Antarctic, which has a size of around 29.8 and 29.6 million square kilometer. It's a wide area around the Antarctic. And deepest ozone hole was observed in 1994, where ozone concentration dropped to 73 Dobson unit on 30th September. So how ozone hole is formed? Here I explain some key features. So what happened during winter? I explained this mechanism for the Antarctic region, and similar mechanism also occur at the Arctic pole. So what happens in winter? This polar region or Antarctic region is completely dark. Sunlight does not reach up to the pole, and temperature drops down to -80°C, which is extremely cold, and this air mass in the stratosphere is extremely dry. So what happens? A vortex formed in the Arctic region which swirls and trap the air mass in the vortex, and this air mass which is trapped into the vortex contains large amount of chlorine and bromine containing compounds. Because of this cold temperature around -80°C, polar stratospheric cloud forms in the vortex. These polar stratospheric clouds are basically thin crystals of ice which contains nitric acid and sulfuric acid. This polar stratospheric cloud plays an important role in ozone destruction processes. They provide a surface for this chemical reaction to occur. So what happens when there are no polar stratospheric cloud, no winter? Arctic region has large amount of chemical compounds, or Antarctic region has chemical compound which contains chlorine and bromine. Here I have shown the reaction for chlorine, and there are some other reaction for bromine. So what happens? These chlorine bromine containing compounds are already present at the Arctic and Antarctic. So they get entrapped into the vortex when it formed in the winter season. But reaction does not take place in winter because there is no sunlight for reaction to occur. So in spring, when that is during August to October, when sunlight reaches to the Antarctic, they provide chemical reaction to occur. So this chemical compound ClONO2 and HCl, they release chlorine. Then this chlorine react with the ozone present in the vortex and cause destruction of ozone. And sometimes ozone values fall to very low values, and when ozone values fall below 220 Dobson unit, ozone hole is formed. So similar reaction also occur in Arctic. But Arctic ozone hole is not as strong as Antarctic. It is less severe than 20 to 25% than Antarctic. This is because Antarctic is mostly surrounded by the oceans on all the sides. But Arctic is surrounded by the land, and that is why temperature at the Arctic Arctic region is does not drop down as low as the Antarctic. Vortex over the Arctic is also weaker, and fewer polar stratospheric cloud forms, and that is why less release of chlorine and bromine compounds, and ozone hole over the Arctic is not as severe as Antarctic. But no matter where it is Arctic or Antarctic, whenever ozone hole form, it penetrates UV radiations which reach to the surface and cause effect to human health and living organism, also crops. UV radiation which are penetrated through the ozone hole into the troposphere has very small role in global warming, since they do not have heat trapping ability as other greenhouse gases. So every year ozone form at Arctic and Antarctic. Some year it is large, some year it is weak, but every year it forms, and we see that smallest ozone hole was observed in 2019 over the Antarctic. But this every year CFCs are emitted, and CFCs has a longer lifetime of 100 of years. So once they are emitted, they remain into the atmosphere for 100 years. So why ozone hole sometimes is weaker and stronger in some years? Since CFCs are emitted, they are there for the hundreds of years. So this variation of ozone hole mainly occurs because of the stratospheric temperature, which controls the vortex formation and polar stratospheric cloud formation. So what happened in 2019? There was sudden stratospheric warming which has increased the stratospheric temperature, and less polar stratospheric cloud forms, hence less reaction of chlorine and bromine occurring there, and less ozone loss occurred, and that is why ozone hole in 2019 was smallest over Antarctic. But scientists says that in Montreal Protocol, we have controlled the ozone depleting substances, their emission into the atmosphere. Observation shows that ozone depleting substances amount in the atmosphere is decreasing since 2000, and it has slowly healed up the ozone loss in the ozone layer in the stratosphere, and it is expected to ozone layer will come back to its original record of 1980, and it may fully filled as old as as it was in 1980 by 2070. But still there is variation of ozone every year because of stratospheric temperature changes, and research is still going on, but they say that these sudden stratospheric temperature changes are related to climate change and global warming. So although we have controlled the ozone depleting substances, there may be impact of climate change and impact of indirectly by the greenhouse gases. Research on this topic is still going on. So the CFCs, or ozone depleting substances, or other ozone precursors such as NOx and VOCs, when they are emitted, they are slowly transported above the tropopause into the stratosphere, and once they reach into the stratosphere, they are transported poleward to the Arctic and Antarctic, and they participate in the ozone hole. So not only CFC which are emitted near the polar region or mid-latitude region which affect the ozone hole, but they are when they are emitted any part of the world, they participate in the ozone hole formation. Therefore, it is very important all over the globe to control the ozone depleting emission of ozone depleting substances and ozone precursor gases. They not only affect the thinning of ozone layer and increasing UV radiations and affect the human life, but they also affect the monsoon processes. They cause climate change, and over the Indian region, their effects are very adverse. They cause reduction of rainfall over the Indian region and may increase the water scarcity issue over the Indian region. So let us today pray that we control this emission of these gases by ourselves as much as we can. And here I stop. Thank you everyone. Thank you for your kind attention.
Thank you, madam. Very nice information you have shared with us, and very fundamental, I can say. So we have to move for the discussion about the and we have some questions regarding that. So last lecture by the Professor Pawar sir, and there are some questions remaining. Can we make artificial ozone, and that artificial ozone can create and we can put it there? So this kind of the question was there. Can you answer it, please? Yeah.
Yeah, artificial ozone means in the troposphere, the CFCs are man-made only. They are not naturally occurring. They are artificial gases, all CFCs. So CFC, once they are emitted in the troposphere, they have longer lifetime of 100 of years. But they do not affect the ozone in the troposphere. They, because of their longer lifetime, and they are inert in the troposphere. Those wavelengths which cause dissociation and reaction formation of ozone does not occur in the troposphere, and therefore once they reach in the stratosphere they cause loss of ozone. Which are artificially produced does not cause increasing ozone in the troposphere, but they reduce the ozone in the stratosphere. But artificial other gases such as NOx, volatile organic compound, they in presence of sunlight they produce ozone. So they are produced from these ozone precursor gases. So if we increase ozone precursor gases, there will be increasing ozone.
Yes. One more question is that भारतीय उपखंड ओझोन किती टक्के प्रमाणात कमी होत चालला आहे? That means over the India, how much percentage of the concentration of ozone is going down? That kind of the question asked by the Sunil Wagmode.
Okay, Sunil, see, ozone in the troposphere is increasing, but ozone in the stratosphere over the Indian region is decreasing. This is because we are increasing the ozone emitting gases, producing gases such as NOx, volatile organic compound. So NOx and volatile organic compounds are increasing ozone in the troposphere, but it is decreasing in the stratosphere at the rate of 2 to 4% per decade. Means for last 10 years there is decreasing stratospheric ozone at the rate of 2 to 4%.
Yes. One more question. Last time when lockdown was started, and that time the news was there, the Antarctica, the ozone hole is again recovering. So that kind of the news was there. What do you think? Is there any man-made affected issue, or it is a natural? So
Yeah,
what do you think about it?
yeah, I have done some study and which is communicated, but not over the polar region, but over Indian region. So when lockdown has occurred, pollution level has suddenly decreased, and NOx amount is decreased by 30% over the Indian region. But what happens in the polar region, in the stratosphere? This ozone hole, as I explained, is mostly controlled by the stratospheric temperature. Okay, so although CFCs they go there and cause ozone loss, but temperature has to be very cold in the polar region. So this temperature control is not that much controlled by these NOx or these man-made pollutants. They are mostly controlled by CFCs and greenhouse gases. So when lockdown, and they have a longer lifetime of hundreds of years. Methane has around 7 years, and CO2 has 100 of years of life. So 3 months of lockdown has not changed their concentration that much. which affect this temperature and cause weakening or strengthening of ozone stratospheric temperature and ozone hole. So, but still studies are going on in this direction.
One more question asked by Dr. Rani Pawar. Effect of lockdown on aerosol formation and tropospheric ozone. Is there an effect of the lockdown
Certain
period?
effect, yes. I have done this study, and this lockdown has decreased the NOx, carbon monoxide, this ozone precursors gases by 30%, and aerosol amount by around 50%. But what happened, although anthropogenic aerosols are decreased, the dust transport which occurs over the from Mongolia and from West Pacific, Sahara and Arabia, these kept occurring. So dust has increased some aerosol, means it has not decreased that much as by the lockdown, but the dust has contributed in aerosol, and there is decrease of anthropogenic aerosol over the Indian region.
We, due to the time limit, we have not considered other. But one more question asked by the Sunil D. How many adoption unit ozone present here? That question is very difficult. I also not understood what is the question. But one more question I would like to ask you. There is so many papers that can represent that the solar proton event when occur. Then at that time, what happen with this ozone hole? Because there is a magnetic fields are open, and how they will be react with that solar proton event. So
So
you,
this time scale of solar photon event is very small, and
uh,
yeah. So actually, I have not seen from this point of view, but
yeah.
I think it is have a small time scale, and ozone hole formation has from winter to spring and for months together. So it may be having some very minimal impact.
Yeah, also Chapman paper have also based on that. That's why I asked you the question. Anyway, it's a very nice discussion, and I
You can
must
give
say,
me other questions. I can reply them.
okay, yeah. So now we can stop here, and thank you very much, madam, for a nice and fundamental information sharing with us. So now may I request to Yashwant Durgud sir to give the vote of thanks. Yashwant sir, please.
Uh, I am very honored to give the vote of thanks for this event. So I am thankful to Dr. S.D. Pawar sir, scientist of IITM Pune, for delivering very beautiful talk on role of lightning in ozone formation in a troposphere. I am also thankful to Dr. S. Fadnavis ma'am, scientist from IITM Pune, for the delivering very beautiful talk on the ozone for the life. Thank you very much. Now, I am thankful to Principal Dr. D.G. Kanche, providing such a platform to get a knowledge of importance of, to get the knowledge and understood the importance of ozone for the life, as well as his support and motivated us. I am thankful to Dr. R.H. Yadav, President, ISRE, Kolhapur Sangli Subchapter, to collaborate with us, as well as I am thankful to Dr. C. Patil, Head Department of Physics, guiding to make this event successful. I am thankful to Dr. Amit Suple sir, IQSC coordinator. I am also thankful to Amol Vande sir for technical support. I am thankful to Dr. P.M. Patil, in charge science faculty. I am also thankful to Dr. Nade DP, coordinator for this event, as well as I am also thankful to Natke NN, is the secretary for this event. So thank you very much. Thank you.
Yes. Thank you all of you. And with the permission of our principal, can we over the program?
Okay. Thank you.
Thank you, sir. Thank you, one and all. Pandey sir? Yes.